Welcome to a special episode of Rethinking Resources. I'm Steve Shade. Our subject for this episode is quite literally a very hot topic, geothermal energy. And we have two special guests to help us explore the depths of this topic. Nina Romich, project expert on low-carbon business at OMV, and Johannes Ettl, senior project manager for well construction. A very, very warm welcome to both of you.
Thanks for having us.
It's great to have you here. Let's set the scene a little bit. In recent years, awareness and knowledge of renewable energies has, of course, increased greatly. But I think if you asked people on the street to name the best sources of renewable energy, most would probably say solar, wind, and hydropower. Geothermal power is often overlooked, even though once we tap into it, geothermal is clean, constant, safe, and unlimited. So Nina, let me begin with you. Humans have, of course, used natural geothermal sources for thousands of years. The Romans built settlements, cities around spas and locations where they found thermal waters. So why does OMV have to drill several kilometers deep if geothermal heat can also be harvested several hundred meters deep?
Well, how deep you have to drill a geothermal well basically depends on two things: the temperature you want to produce and the geological conditions of the respective area. And regarding the geology, we are mainly interested in the temperature increase per depth. On a global scale, you can say that the temperature increases by 25 to 30 degrees Celsius per kilometer. However, there are areas like Iceland where the temperature increases much higher. It might rise up to 150 degrees Celsius. And at some locations, the hot geothermal water even comes to the surface in form of hot springs or geysers. And people have been using these hot waters for hundreds of years, for example, for medical treatments or for bathing. Also the Romans, as you just mentioned. In the Vienna Basin, however, we have geothermal gradients of about 30 degrees Celsius per kilometer. So if we want to produce heat for district heating with a temperature level of 100 degrees Celsius, we need to drill 3 kilometers deep.
Johannes, we'll come back to you in a moment to talk about the technicalities of drilling, where it's advantageous, where maybe not. But Nina, let's stay with you for a very clear question. What is geothermal energy exactly?
Geothermal energy is a form of renewable energy that is stored in rocks and fluids below the Earth's surface. And this heat was generated during the formation of our planet, and it comes from the radioactive decay of materials. And the heat stored in the subsurface is enormous. 99% of the Earth's volume is hotter than 1000 degrees Celsius, so more than enough potential for renewable energy production. Our challenge now is to make use of this renewable and sustainable energy in an environmentally friendly, technical and economically feasible way. And in the past, geothermal energy was used for hundreds of years, but this was mostly done in areas where we faced exceptionally good geological conditions. Now we also want to produce geothermal energy, for example in the Vienna Basin, where we are not in such volcanic and high temperature regions.
Okay, so as you just touched on, not all geothermal systems are the same. Johannes, as an expert on well construction, tell us a bit about different geothermal systems, why some are easier to get at than others.
The easiest one is, or how you can distinguish geothermal systems is, you can distinguish it between shallow, middle, or deep geothermal systems. Shallow geothermal systems, very easy. Everybody who wants to build a house thinks about to drill 1 or 2 wells in the garden, install a heat pump, and with this recovered heat or energy, you can cool and heat your house. This is a very small scale. Then the middle geothermal is more or less for a little bit bigger projects, like if you want to heat public swimming pools or hospitals or sport halls or whatever. Yeah, so you drill wells down to 1,000 meter, 1,500 meter, do the same, install a heat pump in a bigger scale, and heat and or cool with this recovered energy your building. OMV is interested in the third one. This is in the deep one, because here we are talking about a bigger scale. We want to supply energy for cities, for big industries and so on, where the heat demand or the energy demand is quite high. And in the deep, you can distinguish between more or less two major systems. The one is the hydrothermal system, and the other one is the petrothermal system. The hydrothermal system is more or less you're using the hot water, which is in the ground, pump it to surface, let it flow over a heat exchanger, take out the energy, and you provide that for public heating system and so on. Yeah? Petrothermal systems are closed loop systems. Yeah? That means you are pumping a fluid down, get it heated up by the earth or by the rock, and pump it and get it to surface, flow it over a heat exchanger, and provide the heat to your customer.
Okay,
so energy to your customer.
So places located on fault lines are quite literally sitting right on the source. Low-hanging fruit. Okay, we've heard the example of Iceland. In other parts of the world, is it always necessary to drill deeper, or has technology made it possible to tap into adequate heat with less drilling?
Yes, of course. I mean, Nina explained already that you have this geothermal gradient. Yeah? We are talking about 3 degrees per 100 or 30 degrees per 1 kilometer. And in places, for instance, in Croatia or Italy or France even, you have hot spots where you have, for instance, 60 degrees per 1,000 meters. So you just have to drill 2,000 meters and you get the same heat when, for instance, we are drilling down to 4,000 meters. Yeah? So it is possible. The problem here is that heat or the energy heat is not so easy to transport. So if I want to supply, for instance, here wonderful Vienna with public heating, with heat source, then you have to transport it here. Yeah? And you lose a lot of energy when you transported it, for instance, from Croatia. It's much easier, for instance, with gas and oil to transport it, as we know. But heat is a very locally or this heat energy is a very local energy source.
Okay.
Therefore, we are looking to drill wells close to the customer, or we attract the customer to come to us. Yeah? But the easier one is, of course, if you have a big city like Vienna here, to stay outside of Vienna and drill your wells and use it.
Okay, so let's talk about where this is happening and what projects are being looked at. Nina, companies like OMV are showing renewed interest in geothermal drilling. What exactly is OMV exploring right now, and what are the hopes?
We are focusing on developing deep hydrothermal and petrothermal resources, whereas hydrothermal resources always involve water-bearing horizons, so deep water reservoirs in the subsurface. And with petrothermal systems, we do not rely on water reservoirs in the subsurface. We just want to produce the heat that is stored in rocks. Exploring, developing, and operating such subsurface reservoirs is definitely in the DNA of our company. And we can rely on enormous know-how and assets from the last decades of oil and gas production.
Johannes, is there anything you wanted to add to that?
Yeah, I think OMV strategy is to be a major energy provider in renewable energy. And this is our strategy built on, and this is what we want to provide in the near and in the far future.
Considerable, substantial. Here's a question either of you could take, or you can decide who wants to take a swing at this question. Is it necessary to establish new drilling sites every time, or is it possible to drill at existing locations?
It's possible to drill in existing locations, but of course the wellbore need a special design for it. Yeah? We are talking about different diameters in the wellbore, and also it's very important that the casing or the old wellbore, the old casing wall is not corroded, so this is in a good shape. Then we can use it. We have, for instance, a project running in the northern part of the Weinviertel, where we are thinking about where we drilled an exploration well in 2018, I guess. And this one we want to use for a geothermal project, for instance. Yeah. Because it was a dry well. Dry means in respect of oil and gas. We didn't find any hydrocarbons there, so we will reuse it now as a geothermal.
And for members of our audience who are not in Austria, the Weinviertel is a very lovely area about an hour 2 hours away from Vienna. What other locations are really interesting right now? So we know that the Weinviertel is on the cards. Where is the OMV looking at places for future projects?
Yeah, as I said before, I mean, the easiest one is we are going to the customer. So we are looking for cities where already a public heating grid or a public heating system is installed, and we want to replace, for instance, the public heat, which is produced by oil, gas, or coal, or whatever, with a renewable energy like geothermal, for instance.
What are the costs? Is it more expensive, less expensive to drill geothermal wells than oil and gas wells?
Theoretically, it's. People are thinking we are just drilling for water, so that must be more costly, more efficient, yeah, and cheaper than an oil and gas well. But it's not, yeah, because we are dealing with, first of all, we have to drill quite deep. For instance, here in the Vienna Basin, we find oil and gas in a range of 2,000, 2,500 meters. For geothermal, we have to drill 4,000 meters. And it's also, we need to produce more. Yeah? We need to produce more water out of it, because water is carrying the heat or the energy. And therefore, you need a bigger diameter to reduce the friction in the wellbore, yeah? That you don't waste too much energy in. You have to run a pump, for instance, and the pump needs also energy. And when you invest more energy into this pump to bring the water to the surface, then you're producing out of the source, then it's not really economically. So therefore, we have to drill in larger sizes, deeper, and also the temperature is a factor. A lot of tools, what we are running or what we are using while drilling, they don't like heat really, huh? Because there's a lot of electronics inside, and electronics don't like heat really, yeah? And therefore we have to use special tools, and therefore it becomes a little bit more expensive than oil and gas drilling. Yeah?
Even so, there are concerns, even among geologists, that geothermal drilling can set off earthquakes. Are these concerns being taken seriously? What are you doing to address these concerns?
Yes, of course we take it seriously, because that would be if we are creating earthquakes with geothermal, then it would be end of the project. Yeah? What we are doing, I mean, as I said before, we are not activating existing fracs. Yeah? We are using the water comes out of it, yeah? And we are not activating or opening it again. Yeah? I mean, there are huge fracs in the ground. Yeah? So they are because I mean. We are living on plates, swimming on a glue ocean, more or less, yeah? And we are in constant movement. Yeah? For instance, in New Zealand, you have 200 earthquakes per day, yeah? Small one, yeah? And here we have also earthquakes, but we are not want to initiate that. Yeah? Therefore, we are very, very carefully. We are setting, for instance, when we are drilling geothermal wells, we are drilling microphones in the ground where we are measuring this seismic activity. And if you see something that something is moving or starts moving, we have to stop. Yeah.
Nina, let me ask you, are there other environmental concerns that need to be addressed?
Well, when we deal with subsurface fluids, they are always quite salty, and they sometimes contain toxic or dangerous materials. So we have to make sure that we handle this fluid with great care. After production, we extract the heat with a heat exchanger, and then we directly re-inject it into the same formation through the injection well. So a thorough engineering has to take place to make sure this fluid never gets in contact with the atmosphere or with soils. But as we are used to deal with subsurface fluid, I'm quite confident that we will set the right safety measures to tackle those challenges. And in OMV, safety is always a top priority, and if we can't do it safely, we don't do it at all. So I'm confident that our engineers will manage, and we will make sure that it's a closed cycle and the fluid never gets in contact with the environment.
So are there other companies, are there other countries we do need to be worried about? It's great if OMV is erring on the side of caution, but do we need to be worried about this technology being used by less responsible players?
I don't want to judge on that, to be honest. Yeah, of course there are, let's say, more or less companies. They see it a little bit in the cowboy mentality, yeah, and don't take care too much on safety. But here in Europe, especially in the middle Europe, we are on a very, very high safety level, and I think all companies dealing with geothermal here, they are aware of that, and they're dealing the risks. Yeah.
So, Johannes, let me lean on your scientific expertise again. There are legitimate worries about deep drilling causing the cool down of the Earth's core. Okay, is this a legitimate concern, or is this an urban legend?
It's an urban legend.
Okay, we're not going to let the heat out of the core of the planet.
No. First of all, you cannot waste energy. Yeah, energy is always there. You just transform energy. Yeah, this is one thing. And another thing is, as Nina explained, I mean, 99% of the Earth, of the volume of the Earth, is hotter than 1,000 degrees. And no, we will not cool it down.
Okay.
By human standards, we can say that geothermal energy is infinitely available.
So here it comes again. It sounds too good to be true. So Nina, let me ask you, why hasn't geothermal energy been embraced on a larger scale? Several years ago, the International Energy Agency mapped out a very optimistic growth scenario, but interest in the technology has, quite frankly, remained lukewarm. What is holding it back?
Well, there are some obvious advantages linked to geothermal energy when it comes to environmental advantages, or also the constant availability, which is the biggest advantage of geothermal energy compared to other renewable sources like solar or wind. But we have to be frank here, there are also some challenges you have to overcome, and especially upfront investments. When you want to find those geological reservoirs, you usually need quite expensive subsurface measurements. Additionally, there is always the risk that a geothermal project is not successful, which would mean that all these expenditures you had before are just lost. So I could imagine that in the past, probably other technologies were cheaper and bared less risk. But now I think it's the right time, considering the very low carbon footprint and the small environmental footprint, that it's the right time now to bring geothermal out of its niche status.
Johannes, it does seem that dozens of countries are poised to make a move when the price is right. The Global Geothermal Alliance, or GGA, remains pretty gung-ho on building up support for geothermal energy. So do you see, or do you expect some positive tipping point to commit to geothermal and massively expand its usage?
Yes, because honestly, Nina already said that what you can do with geothermal energy, it provides you a base load. Yeah? It builds a rock solid fundament or basement for your energy mix. Renewable energy, as we know, for instance, windmills or photovoltaic or this kind of source, you're always depending on weather conditions. Yeah, and photovoltaic in the night you have no sunshine. Yeah, and you're not producing anything. Also here in this. Vienna is a windy area, but there are days and where it's clouded, where you have no sunshine and when you have no wind, or it's foggy or whatever. What you're doing then? Yeah? So you need an energy source which provides you a constant basement for district heating, for whatever you use your energy. Yeah? And this can geothermal energy provide you. Yeah? Because you are harvesting, once you drill a doublet or a geothermal well, you can harvest it for 40 years. Yeah?
So Nina, let's look into the crystal ball and forecast the future. I recently heard one energy industry expert compare geothermal today, its status today, to what smartphones were like in the 1990s, meaning that she expects massive growth in popularity in the coming years. So as you look into your crystal ball, look to the year 2030 and beyond, do you see geothermal energy becoming as ubiquitous as smartphones?
I don't think that geothermal energy will be as omnipresent as smartphones. Also, if you consider the execution time of such projects, for sure not by 2030. But I do think that there will be a massive growth in the number of geothermal plants in Europe and beyond. And I also think that geothermal energy could play an important role in reducing our carbon emissions and will help to pave our way to carbon neutrality.
And Johannes, what do you see in your crystal ball?
More or less the same as Nina. Yeah? I think it will grow, yeah? And it will be a substantial part, as I said before, a basement for the energy mix what we are using. Yeah? But also we have to be realistic, to be honest. I mean, hydrocarbons will stay in this energy mix for at least for the next 20 years. Yeah? But geothermal, the portion of geothermal and renewable energy will be much bigger in the future. And this is what I see. I see a great future for geothermal energy. This is the reason why I joined it.
Okay, that's where we will leave it. Nina Romich and Johannes Ettl, thank you so much for joining us and sharing your thoughts, your ideas, and your insights with us on Rethinking Resources. To everybody listening, to everybody watching on the OMV's YouTube channel, if you have feedback, if you have questions, please send us a message to podcast@omv.com. We would love to hear from you, and you will, of course, get a response. For more background information on the topics we discussed in this episode and on our guests, check out our show notes where you'll find links to lots of valuable information. Thank you so much to our guests. Thank you so much to people in the audience. We hope you will join us again for the next episode of Rethinking Resources.